Okay, good afternoon again, everyone. Welcome to a brand new week for Math 155. But first, I'll apologize in advance. Inaatake na naman ako ng allergy ko. Hindi ko alam kung allergy to or something. Nung nagsimula ako mag-klase kanina sa kabilang 155, 11:30, medyo runny nose na, medyo may itchy feeling na. Alright. Buti hindi ako nag-sneeze kasi problema ko rin yun. Hindi talaga ako makapag-focus pag masyado nag-sneeze. Pero may runny nose. I don't know dahil ba sa panahon or what. So I'll uh, I'll need to turn off my mic for some time later repetitively para lang maayos yung yung runny nose ko. So I'll apologize in advance for that. I don't know what's the cause of this, pero siguro ito nga yung summer feeling na super init ngayong hapon. All right. And then what else? Okay. Now I have another boo-boo in the problem set. So for those who are still working on it, siguro this might help. All right. In problem number 3, nakita na to ni Ana. When I was grading Anna's work, saka ko lang napansin yung typo dito sa number 3. So I will be voiding the second part ng number 3. Itong follow-up question about analogous result for the infimum and supremum of A intersection B. So if you're still working on it, don't bother answering the second question. Just focus on proving that the formula for the infimum and supremum of the union. Okay? Ano yung kamalian ko rito? Nasulat ko ay A intersection B equals the empty set, right? So if A intersection B is empty, then there's no point in talking about formulas for A intersection B. So that will just be, or that will just boil down into finding a convention for the infimum and supremum of the empty set. Okay, and it will depend on the conventions that you will use. Pero usually, yung convention para sa infimum at supremum ng empty set ay nasa extended real number system na. So it's either positive or negative infinity, which unfortunately we did not do in class kasi nga sa klase confined tayo sa mga real numbers. So yeah, dapat ang sinulat ko ay A intersection B is not equal to the empty set. So sorry about that, guys, kung medyo uh, nag-consume kayo ng brain cells para isipin yun. I'm sorry about that. Kilala nyo naman ako, I'm king of typos. So, yeah. So, dapat ganito yung tanong. Siguro, next semester ko na lang ibibigay itong question na to. So, yeah, don't bother answering that. And then, do you have any questions or comments, further clarifications about the problem set? Dun pala sa problem set, dun sa true or false na question, I momentarily suspended the display of the explanations why, all right? Para lang hindi kayo ma-attempt na screenshot at para hindi siya mag-leak or kumalat. Baka accidentally ma-send nyo sa isa nyong classmate or ma-discuss nyo with another classmate of yours who haven't submitted their answers to PS 1.5. So, winitold ko muna. Pero siguro once the submission is closed later today, i-display ko na yung final answers and the explanation kung bakit true or bakit false yung statement. So pwede nyo na siyang i-download or i-print as PDF, okay? Yung page na yon para ma-review nyo or para ma-double check nyo kung tama yung sagot ko. Alright? But just don't send it to your other classmates kasi baka nag-request sila for late submission or for extended deadline. All right? Due to some valid reasons. Okay? So yon. Pero next time I'll probably make it instant na makita nyo kagad yung sagot. But just promise me not to share it with your other classmates. So it's just for your own consumption. Okay? What else? So deadline is tomorrow. So hopefully you are about to finish it. So kung meron na kayong mga natatagong items na tapos na, submit niyo na para masimulan ko na siyang matcheckan. I'll try to do that later today. Sana umayos yung runny nose ko later. So sana mawala siya. Okay, so now I'm going back to the lecture notes, but I think naghang yata yung display ko. How about on your end, guys? Naghang din ba siya? Prime time kasi talaga tong 2:30 to 4, agawan sa bandwidth. Stuck din ba dun sa problem set 1? Lag yata. All right, so let me restart. Nasa note switcher pa. Okay. So at least sync naman yung nasa laptop monitor ko. So, okay. Pero call my attention if something is wrong or nag-stuck siya. I'll try to reset and hopefully it will work fine. Okay, so there we go. So last time I think we were talking about sequences, and actually there's nothing fancy or new with this. You have already seen this in your calculus courses. So basically we said that the sequence is a function whose domain is the set of natural numbers to the set of real numbers, in a sense that we are assigning to each natural number a distinct real number, a sub n, right? And then we look at different ways on how to represent a sequence. So you can simply say, you can just enclose the formula for a sub n inside the brace. And if it's the context is clear, then we all know that this will stand for a sequence rather than a singleton, all right? By the way, when we say singleton, yan lamang yung mga sets na iisa yung laman. Dual tone, sila yung mga sets na dalawa lang yung laman, and so on. All right? So if you're looking at it from a general set theory perspective, singleton lang yan. Pero pag nag-uusap tayo about sequence, that it is clear in the context of the sentence or the paragraph that we are talking about sequences, then treat this as a sequence. But if you don't want to create some ambiguities, pwede mo naman siyang isulat ng ganito. Lagyan mo ng subscript to denote that the index starts at n equals 1 and it goes without bounds, or it increases without bounds. So ganyan. Then another way is to list down the first few elements of the sequence and then stop when the pattern is apparent. All right. So pwede mo isulat A1, A2, A3, and so on. So pwedeng may A yan dyan, tapos dot, dot, dot. Okay? Now, we are listing it. Iba siya dun sa set notation. All right? Again, if you're thinking of it as a set, then it will just be a listing of the members of the set. But in the context of sequences, this is an ordered list. All right? We're in ordering of the elements matter. Ibig sabihin, pag meron dyan dalawa na nag-switch ng places, then that's another sequence. Because again, when we are listing the first few members of a sequence or the first few terms in a sequence, it is our understanding that the first element is the function value of 1. A2 is the function value of 2, and so on. So listed sila in the natural ordering of the natural numbers. Okay? And then we said that the business of analysis is not just looking at the first few terms, but what we're more interested in would be to see what happens at the tail end of the sequence. Ano yung nangyayari kapag ka malaki na yung subscripts, okay? So what happens in the long run? Ano yung behavior ng mga terms na nandoon sa sequence, all right? And we say that this sequence will converge to a real number A, all right? Our notation, we can just say this sequence, arrow A, ibig sabihin, A sub n converges to A, or we can write limit of A sub n as n approaches infinity equals A, if and only if, in layman's terms, habang lumalaki yung subscript, palapit ng palapit yung mga terms ng sequence kay number A. So ibig sabihin, the terms in the sequence accumulate at A, especially for large indices. All right? And how do we quantify yung accumulation na yon, or how do we say na malapit na yung mga ANs kay A in a mathematical way? All right, excuse me. Ganito natin siya kina-quantify. So that will happen if and only if, oh, by the way, it's a usual mathematical jargon. IFF is our abbreviation for if and only if. So if and only if for all epsilon greater than 0, however small it is, we can always find an index capital N, right? Or a natural number capital N, such that whenever the index little n is greater than or equal to n, then we have this inequality. Okay? So it is saying that however small your epsilon is, okay, you can always find a starting index after which the distance between the terms in the sequence and the number a is less than epsilon. Ibig sabihin, kahit gaano mo papiliin yung epsilon, gaano siya kaliit, laging merong starting index na pag lumampas ka na sa index na yon, yung layo mula kay AN papunta kay A ay mas maliit na dun sa epsilon mong pinili. The key here is you can do this for every epsilon greater than 0. So if you will laymanize this bunch of alien-looking symbols here, okay, you can say okay, um, for whatever epsilon you choose, laging merong sufficiently large subscript that will guarantee that the term in the sequence is within epsilon units away from the supposed limit A. All right? And then sinabi natin na kapag ka naman yung negation nito totoo, then we say that the sequence will not converge to the number A. So that means if we can find an epsilon greater than 0 such that for all natural numbers capital N, there will exist a little n greater than capital N such that this inequality will be true. So, hindi naman siya magko-converge kay A kapag nakakita ka ng isang epsilon kung saan merong sa lahat ng natural numbers capital N, laging merong term ng sequence na yung distance mula kay A ay mas malaki dun sa napili mong kahit isang epsilon. Okay? So if there is no real number to which the sequence will converge, then we say that that sequence is a divergent sequence. All right. But of course, we are more interested with convergent sequences. All right. So yun yung titingnan natin. And we look at some specific cases of sequences last time. Nag-prove tayo using the definition. Okay. And it's quite tedious to prove it using the definition kasi nga for all epsilon yan, kailangan mo maghanap ng capital N. Okay pa yung mga examples natin kinonsidered last time, pero for more complicated sequences, that might be a very daunting task. So later today, we'll look at some theorems that will help us evaluate or to see if a sequence will converge and to what value, if we will be able to write that sequence probably in terms of some algebraic operations on two sequences na alam na natin kung saan nagko-converge yung mga kung saan nagko-converge. Okay? So yun yung algebraic limit theorems that we will look at today. And also last time we look at an example wherein we were able to prove that the sequence diverges. In particular, we look at the alternating sequence -1 to the power n. Ito yung ang laman niya lang ay -1, 1, and so on. And we proved the impossibility of this sequence to converge. Kasi tinest natin lahat ng possibility kung saan siya magko-converge. Well, first off, obvious na hindi siya pwedeng mag-converge sa real numbers aside from 1 and -1. Kasi nga, ang titingnan natin ay yung behavior in the tail end. Alright? Tapos dahil dalawa lang yung possible values ng sequence, so sure tayo, magko-converge lang siya sa positive or -1. But unfortunately, we were able to find an epsilon for which the definition will not apply, all right, kung i-assume natin na yung limit ay 1 or -1. So that's a neat way of showing that this sequence is divergent. But you see, there's a lot of work to be done in that case kasi kailangan pakita natin na imposible siyang mag-converge sa kahit na anong real number. So our hope as well is to find some easier criteria to show divergence naman. Okay? So, and then siguro along the way, we can discover some of these when we investigate some theorems regarding convergence. Okay? Now, after the pre-show, eto na. So, new things that we will learn today. So, dahil nagagawa pa siguro kayo ng problem set or still finalizing it, let's just look at some of the results that you are already familiar with. Tapos tingnan lang natin yung mga proofs nila. Probably you have also seen these in Math 38, pero maganda na i-review natin sila kasi yung mga bagay na ginamit dito sa mga proofs nila ay posibleng makatulong sa atin when we try to prove some more complicated statements. All right? So the first theorem is the uniqueness of the limit. We know that if you have a sequence, it will either converge or diverge. But the nice thing is that if the sequence is convergent, then we know that there is a unique limit. All right? Hindi pwede na meron kang isang sequence na nagko-converge sa dalawang magkaibang values. So pag nagko-converge siya, automatic na unique yung limit. Okay? That's why we are using the article the instead of the article pag describe ng limit. Kasi nga, pag may limit, siya dapat ay unique. And probably from Math 101 or previous math courses or major courses, alam nyo na, yung dalawang, usual template. Pagpo-prove ng isang sequence ay, pagpo-prove ng isang bagay ay unique or hindi. Alright? So you can do it in two ways. Ito yung sinasabi ko sa 101 students ko. Usually, we do a proof by contradiction. So proof by contradiction or an indirect proof, all right? So pagpo-prove ng uniqueness. So usually, you start your proof by supposing otherwise. So you suppose there are two different numbers, A not being equal to B, such that the given property holds. Okay? Tapos, ang goal mo, gumamit ng logical arguments from your assumptions and so on, tapos mag-come up ng isang contradiction. Okay? And the usual contradiction na nakukuha sa ganitong klase ng proof by contradiction ay A being equal to B. Yan yung usual na contradiction na nakukuha natin na using some results or some consequences of some results, mapapakita natin na necessarily A is equal to B, which violates your initial supposition that A is different from B. Pero you can rewrite this. If that's your contradiction, then it's very easy to rewrite this into a direct proof. Okay. And I think this is what is done in the lecture notes, okay? Pag direct proof naman yung gusto mong approach, so you assume that there exists two numbers. There exists real numbers, say A and B, such that the property that needs to be proven is true. Okay. Suppose mo may dalawang real numbers na nagsasatisfy. And look at this. I'm not assuming that they are not equal to each other. Kaya hindi to proof by contradiction. Kaya siya nagiging direct proof. So assume mo lang, kunwari, meron dalawang numbers kung saan totoo yung gusto mong i-prove. And then, then your goal is to show ultimately that A is equal to B. Okay? So pag nagawa mo yan, meron ka ng direct proof. Okay? And so here, there's a very strong correspondence between these two guys. So it's just a matter of choosing your style or kung paano mo isusulat yung template. So pwede mo siyang isulat as a proof by contradiction. I-assume mo lang na sila ay hindi equal sa isa't isa. Tapos ultimately, pakita mo na by hook or by crook, there should be equal to each other. Or use a direct proof. Huwag mong i-assume na sila ay equal na sila ay equal sa isa't isa, but ultimately you use some arguments to show it. Okay? So I think the handout used the latter. So let's look at the proof. But you'll need to excuse me for a minute. Buti na lang online class, hindi nyo nakikita yung itsura ko ngayon. So, hirap na ako sa running notes ko nito. Alright. So, yeah, isa sa mga advantage ng remote setup. Okay. Alright, so let's look at the proof. Okay. So, I think the proof is written in a direct fashion. So, ginamit ko nga yung latter. So, let's see how. Okay. Now, first, of course, we'll work with our assumption. The assumption here is the limit converges. Okay? Meron na siyang limit. So, suppose natin na, okay, nagko-converge siya. And since I want to show that the limit is unique, then i-assume ko meron akong dalawang real numbers that serve as the limit of the sequence. Okay? And then I will apply the definition ng limit kay A, sorry, kay A at saka kay B. All right? Now, for any given epsilon greater than 0, okay, I will be able to find a capital N1 such that right after N1, the distance between AN and A is less than epsilon over 2. And now you might be thinking, where did epsilon over 2 come from? First thing is that this is perfectly fine because the definition says for all epsilon greater than 0, blah, 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 inequality is true. This guy will be less than any epsilon greater than 0, any arbitrary epsilon greater than 0. Now, our assumption is that epsilon is greater than 0, so that means epsilon over 2 is also greater than 0. Dahil totoo siya sa lahat ng positive number, yung definition ng limit, alright? Tapos si epsilon over 2 ay positive din. So syempre, dapat may mahanap tayo na starting index capital N1 para kay epsilon over 2. All right? So I don't think that's a big of an issue there. The bigger question is, why did I choose to use epsilon over 2? Out of the many options, I could have just written epsilon over here, or I could have chosen epsilon over 3, epsilon over 5, or whatnot. Okay? Bakit of all those possibilities, epsilon over 2 yung napili ko? Well, we will see that later. Okay? Makita nyo kung bakit, and probably I'll say a couple of words paano natin ginagawa yung proofs kung hindi ka sure na epsilon over 2 yung tamang ilagay dyan, and so on. Okay? But for now, bear with me. Just go along and accept na, okay, epsilon over 2 yung napili for whatever reason. Okay? So that's applying the definition to the limit A. But again, we are assuming that the sequence also converges to B. Okay? So that means for the same choice of epsilon, namely epsilon over 2, we can find another starting index, say capital N2, such that after capital N2, this inequality is true. All right? So just a technical detail here, I needed to choose a different starting index N2. Kasi yung convergence ni AN kay A, all right, ay nakadepende sa inequality na to. And we need to find sufficiently large indices such that this inequality is true. Dahil yung pangalawang inequality ay nagsasabi ng something about the limit B. So therefore, hindi natin sure na yung starting index na N1 para kay A ay mag-hold pa rin sa starting index na A2 para kay B. Because if you will sort of illustrate this, okay, parang ganito yan. So, halimbawa ito si N1, sure tayo by the definition of the limit na kapag ka lumampas ka na kay N1, so nandito ka na kay N1 plus 1, N1 plus 2, and so on. So ito yung mga capital N's natin. Totoo yung inequality na AN minus A less than epsilon over 2. Okay? Kaya lang, pag in-apply natin yung definition nung ng limit, dun naman para naman kay B, all right? Hindi natin sure kung yung N1 na to, siya rin yung starting index that will guarantee the analogous inequality for B, all right? Posibleng meron ka diyang isang N2 such that simula kay N2, totoo itong inequality na to. All right? Para sa mga little n's na dyan, totoo yung AN. Okay, hold on. Totoo yung absolute value ng AN minus B less than epsilon over 2. All right? So si N1 hindi necessarily equal kay N2 because you are applying the definition in two different limits, all right? Even though they are sharing the same choice for epsilon, parehas epsilon over 2 yung gusto nating ma-attain na bound. Pero hindi natin nag-guarantee na parehas yung starting index that we need for this two. All right? So that's it. That's why I needed to choose two different starting indices. And then remember that I want to show that A is equal to B. All right, so yun yung gusto kong mangyari. So I'll investigate, how do I show that that A is equal to B? Well, I can do so by looking at the absolute value of A minus B. All right, gusto kong makita kung ano yung absolute value ni A minus B kasi I'll be able to show that that A is equal to B if this magnitude is equal to 0. Okay? So, yun yung isang paraan. So, mapakita yung absolute value na yan ay equal kay 0 para makonclude na si A ay equal kay B. Now, how can I do this, right? But look at what we have. We have these two inequalities to work with. Meron kang A, meron kang B, nasa loob ng absolute value, and my plan is to show that this is equal to 0. So how can I manage to do that? Well, I'll need to write this inequality in some form such that I'll have these two guys or these two absolute values. So meron na akong A, meron na akong B, so kulang na lang ako ng mga ANs. So this is a usual trick in analysis proofs, okay? We can add and subtract the same thing to whatever quantity we're working with, okay? So in this particular case, we're working with A minus B inside the absolute value. So probably here I can add and subtract A sub n. Kasi nga, if I investigate the two inequalities that we know, all right, meron siyang AN, at saka si B. Eh, meron ako dito A at B pa lamang, so why not add and subtract A and B to them? And then here, I'll just need to rearrange some terms, okay? Para masulat ko to as absolute value ng A minus AN minus quantity B minus AN. All right? So, ni-rearrange ko lang sila. Okay? And then I will use a triangle inequality sa statement na to. So, I'll have absolute value ng A minus AN plus absolute value ng B minus B minus BN. Sorry, B minus AN. Tama pa yung pinag-jumble ko plus yeah, I think that's fine. Tapos para masulat ko siya ultimately in this form, all right? So pwede kong pagpalitan yung roles nila by just multiplying absolute value of -1 to these two guys, all right? Tapos kasi ang absolute value ng -1 ay equal lamang kay 1, so that's perfectly valid. Then this -1 multiplier can go inside of the first factors. So we'll have ultimately this, A sub n minus B sub n. Okay? So kaya ako nakuha yan. At ito yung dahilan kung bakit gusto ko parehas lang epsilon over 2 yung bound para dito at saka para dito. Kasi nakita ko later in the proof na pag-a-add ko pala yung left-hand sides nitong dalawang inequalities na to. So that means I'll need to have an epsilon over 2 here and another epsilon over 2 here. So when I add them up, I'll get the epsilon that I wanted. Okay? Or actually, it's not required to have epsilon over 2. Pwedeng ito ay epsilon over 3, tapos ito epsilon times 2/3, which is perfectly fine. So you can be creative with it. You can use epsilon over 6, and then here you'll use what? You'll use 5 epsilon over 6. That's perfectly fine as long as they add up to epsilon. Okay? Pero merong isang maliit na detalye na kailangan ko makita. All right? Note that these two inequalities will not work for all natural numbers n. These two guys will only work for sufficiently large little n's. In particular, the first inequality will only work for little n's that are greater than n1, and this one will work for all little n's that are greater than n2 or greater than or equal to n2. So that means, all right, hindi siya nag-work sa lahat ng little n. So kailangan piliin ko yung subscripts to be large enough so that these two guys will hold at the same time. Okay? Tapos balikan natin yung drawing natin kanina. Totoo to sa lahat ng mas malaki kay n1, okay? Then ito ay totoo sa lahat ng mas malaki kay n2. All right? Now, how can I guarantee that the two inequalities will be true at the same time? Sige nga, any suggestion? How can I guarantee little n is large enough para masabi ko na okay, totoo itong dalawang inequalities na to, so I can use them in my proof and add them up to get the epsilon that I wanted. Okay, how can I choose the starting subscript? Sige, 30 seconds to think for bonus recitation points. Yeah. Paano ko mapipili yung starting index? Alright. Sorry, nagbasa ako ng messages late. Late ko nabasa yung question ni Gian. Yeah. Kasi 'di ba, ito ay nagwo-work lang kapag ka si little n mas malaki na kay n1. Ito nagwo-work lang kapag ka si little n ay mas malaki na kay n2. Pero gusto ko silang sabay na maging totoo para mapag-add ko sila, makuha ko tong statement na to. Alright? So how can I choose little n, or how can I guarantee that little n is large enough so that these two guys will happen at the same time and therefore allowing us to add the respective sides? Sige, another 30 seconds habang magre-reply lang ako. Okay, walang gustong mag-try? Okay. Now, how do we guarantee? Well, parang ganito yan. Let me try this one. Okay. So gusto ko sabay silang mangyari, right? Meron palang try si Charles, N1 plus N2. Well, I think that will work, N1 plus N2, kasi nga kapag ka totoo siya kay N1, tapos totoo siya kay, kapag ka si little n ay mas malaki kay N1, kapag ka si little n ay mas malaki kay N1 plus N2, siguradong mas malaki na siya kay N1 at mas malaki na siya kay N2. Thus, the two inequalities will be true. Yeah, that's correct, Charles. N1 plus N2 is a valid choice, all right? Though though masyado na siyang malaki kaysa dun sa kailangan ko, but that's perfectly fine. Existence lang naman yung hanap natin, di ba? Sa definition ng limit, there exists a capital N lang na starting index. So N1 plus N2 will work. Another one or another choice would be the larger between N1 and N2. So pag juxtapose ko to, halimbawa nandito si N2, dito siya. Okay. Gusto kong maging totoo yung inequality, pero tingnan nyo, kung mas malaki si N1 kaysa kay N2, so ibig sabihin, pag lumampas na ako kay N2, lampas na rin ako kay N1, so totoo na yung dalawang inequalities. Now, kung baligtad naman na si N2 yung mas maliit kaysa kay N1, okay? Totoo yung inequality, yung second inequality, dun sa mga mas maliliit kay capital N1, pero hindi ko pwedeng piliin yon kasi hindi naman totoo yung first inequality pag hindi pa ako lumalampas kay N1. So the safer choice in this second case is N1. Kasi pag lumampas na ako kay N1, mas malaki na yung mag-hold na yung first inequality, tapos mag-hold pa rin yung second inequality. So I will choose the larger one. Yung sa dalawang scenarios na pinakita ko, mag-work yung dalawang inequalities kapag ka pinili ko si capital N to be the larger between N1 and N2. Okay? So if that's the case, then I'm sure that if that's capital N, then kapag ka lumampas na si little n kay capital N, ibig sabihin lampas na siya parehas kay N1 at saka kay N2, mag-hold yung dalawang inequality, and then we'll get this result. Okay? So essentially, what we have shown here is that the absolute value of a minus b is strictly less than epsilon. Okay, but this is an absolute value, so we know that that is non-negative. So alam ko rin na 0 is less than or equal to the absolute value. Okay? And then ito na yung trick na kailangan ko talagang gamitin. Eh ano naman sir, kung yung absolute value ng a minus b ay mas maliit kay epsilon, what do we get from here? Okay? Now, the thing here is that um, remember, epsilon is chosen arbitrarily. So si epsilon ay kahit anong positive number. So we're saying here na si absolute value of a minus b ay non-negative. So it's greater than or equal to 0. Tapos siya ay mas maliit sa lahat ng positive real numbers. So we have here 0 less than or equal to absolute of value of a minus b less than epsilon for all epsilon greater than 0. So itong absolute value na yan ay mas maliit sa lahat ng positive numbers. So it makes sense to say na, oh, kung mas maliit siya sa lahat, strictly, mas maliit siya sa lahat ng positive real numbers, so dapat equal siya kay 0. Alright? Kasi kung hindi to equal kay 0, isa siyang maliit na positive real number, well, there would be a smaller real number, pero dapat mag-hold siya sa lahat ng epsilon. Dapat mas maliit na siya sa lahat ng epsilon. So kung ito ay isang maliit na positive number, baka naman may positive number pa na makakasingit na mas maliit sa kanya, which is impossible because we want this to be true, or we know that this is true for all positive real numbers. So yun yung intuition dito. Kapag ka nakita ka ng ganito, natotoo siya sa lahat ng epsilon greater than 0, so dapat itong nasa gitna ay equal kay 0. Kasi kung hindi siya 0, imposible nang maging mas maliit siya sa lahat ng positive real numbers. Okay? Which makes sense intuitively, all right? Pero kung gusto niyo analytic naman, yung argument, pwede niyo balikan yung lemma 1.1. Ito yung sinabi ko na magagamit natin from module 1 or from the previous lecture note, all right? Ang sabi nito ay if a is less than b plus epsilon for all epsilon greater than 0, then ang a ay less than or equal kay b. I don't know if this was the exact statement of lemma 1.1, but this is an alternative version, at least, of lemma 1.1. Okay? Kapag ganito siya. Tapos, pwede ko itong i-apply dito sa inequality na to. Alright? Now, I can write epsilon as 0 plus epsilon. So, and then I'll compare it with the lemma or with the assumption of the lemma. So itong absolute value of a minus b, siya yung left-hand side. So pwede ko siyang i-treat as the a nung lemma 1.1. Tapos yung 0 na naka-add kay epsilon, pwede ko siyang i-treat to be the b dun sa lemma 1.1. So that means this will tell me that since this is true for all epsilon greater than 0, then yung a dun sa lemma 1.1 ay dapat less than or equal dun sa b nung lemma 1.1, which is 0. Okay? And then I'll conjunct this with our prior knowledge that the absolute value is greater than or equal to 0. We get this inequality. All right? And then what does this tell us? We have a number that is greater than or equal to 0 and at the same time less than or equal to 0. And this will happen even only if that number, the absolute value of a minus b, is equal to 0. Tapos, ang absolute value, nagzi-zero lang yan kapag kayong nasa loob ng absolute value ay equal kay 0. So we know that a minus b must be equal to 0. Therefore, a is equal to b. Alright? Tapos ano yung napakita natin? Napakita natin na pag nagko-converge yung isang sequence kay a at saka si b, necessarily, dapat si a ay equal kay b. And hence, the limit is unique. Okay? So that's the proof of 2.1. Any questions? Probably ni-stretch ko yung proof with so much details, with more details than needed. But I think that's a good exercise. At least we are dissecting the proof and inserting all the details that were skipped. Right? Magandang exercise din to pag nagbabasa kayo ng mga proofs. All right. Any questions? Clear? Yes, Anna?
Sir, question lang. Paano po yung Archimedean property na may number daw between 0 and epsilon?
My number between 0 and epsilon? Yes, that's true. By the Archimedean property. But what about it?
Yung sa proof po na absolute value ng a minus b, tapos naging equal to 0 siya. Kasi pag mas maliit siya kay epsilon, 0 na po siya.
Uh-huh. So you're thinking about an alternative proof para mapakita na si na si absolute value of a minus b equal kay 0 instead of using lemma 1.1?
Ano sir, bakit po naging equal to 0 na siya? In-assume natin na equal to 0. To 0 na siya, yung Archimedean principle ay may number pa pala between 0 and epsilon.
Okay. May number pa between 0 and epsilon. Yeah, you're right. Okay. So ganito kasi nangyari, no? Ganito tayo nag-start. Okay. So, kaya lang ito ay greater than or equal. Alright, so yun yung meron tayo. Ayun, ano nga ba meron tayo? Okay. Absolute value of a minus b. Strictly less than pala to, no? Strictly less than. Well, okay pa rin naman siya. Absolute value of a minus b is strictly less than epsilon. Okay. Tapos, ang sabi natin ng Archimedean principle, laging may mas maliit pa na number kaysa kay epsilon. Pero yung number na yon ay dito siya papasok. Or pwede nga rin pala siya dito sa kabila, no? May mas maliit pa na real number para sa kanya. Pero ang idea rito ay, hindi kasi to existence lang. For all epsilon, may mas maliit pa na number sa kanya. Yeah, that's true. This is true for all epsilon greater than 0. Okay. So, nasabi natin dito ay si absolute value of a minus b ay mas maliit kay epsilon. Okay? Now, you can... siguro yung sinasabi mo, Ana, ay yung nandito naman na mas maliit kesa kay a minus b. Tama ba?
Yes po, sir. Ginawa natin equal to 0.
Right. Kasi ayaw mong tanggapin na equal siya kagad kay 0, ano? So, kunwari dito ay posibleng may small number pa sa pagitan ni 0 at saka absolute value ni a minus b. Tama? So, ito yung tinright kong i-avoid by using lemma 1.1. Sa lemma 1.1 kasi, kapag ka meron ka ng kapag ka alam mo na si a ay less than kay b plus epsilon, at totoo ito sa lahat ng epsilon greater than 0, so sure ka na si a ay less than or equal to b. Alright? Kasi nga, totoo to sa lahat ng epsilon greater than 0, so magdagdag ka lang ng konti kahit katiting kay b. Alright? Magagaranti mo na si a ay mas maliit na kay b. So mangyayari lang yon kapag ka si b in the first place is greater than or equal to a. All right? Kasi kung mas malaki pa si a kaysa kay b, then hindi na to mag-work for all epsilon greater than 0. Okay? So kaya ang ginawa ko, in-apply ko si lemma 1.1. Tapos nung ginamit ko si lemma 1.1, ito yung nakuha ko. That this guy ay nawala na si epsilon, naging less than or equal to 0 na to. Kasi tama ka, baka magkagulo tayo using Archimedean principle kapag ka epsilon pa rin yung pinag-workan ko dun sa final inequality. So to avoid that loophole in the proof, tinanggal ko yung epsilon. Paano ko natanggal si epsilon? Theorem 1.1. Sure ako na ito ay totoo for all epsilon greater than 0. Kaya lang nag-insert ako dyan ng 0 plus epsilon. So absolute value of a minus b is less than 0 plus epsilon, which is fine because that is still equal to epsilon. All right? Pero sabi ng lemma 1.1, kung totoo yan, dapat ito ay less than or equal na kay 0. Okay? Kaya, nag-guarantee ko na 0 na yan. Nawala na sa picture si epsilon. Alright? Si epsilon na arbitrary small number. Ang alam ko na ngayon, yung absolute value ng a minus b ay less than or equal to 0. Okay? So, napakita ko ngayon, si absolute value of a minus b ay mas malaki kay 0, pero mas maliit is mas malaki or equal kay 0, at saka at the same time, mas maliit or equal kay 0. So ngayon, anong nangyari? Wala ng number sa pagitan ni 0 at saka ni absolute value of a minus b. Kasi nga sure ako, ito, mas malaki kay 0 using first principles ng absolute value. And then as a result of lemma 1.1, I'm sure that this guy is less than or equal to 0. So wala ng epsilon sa pagitan ni absolute value of a minus b at saka ni 0. Wala ng maliit na real number sa pagitan nitong dalawa. So therefore, absolute value of a minus b ay dapat talaga equal na kay 0. Okay?
Okay na po, sir. Thank you po.
All right. So, yeah. So that, I think that ends the proof ng pagiging unique ng limit ng sequence if it exists. So now, the thing about convergence, it boils down to two cases now. Either the sequence will not converge or it will converge to a unique real number. Okay, so yun yung takeaway natin from Theorem 2.1. Okay, now we'll try to develop a necessary condition para sa isang convergence sequence, all right? And from there, deduce a divergence criterion, okay? But before that, we'll need to look at definition 2.4, all right? Dito i-define natin yung pagiging bounded. Kailan nagiging bounded ang isang sequence, and you will see that this is a direct implication ng pagiging bounded ng isang set. All right? So masasabi natin ng isang sequence ay bounded kapag we can find a positive number capital M such that the absolute value of all terms in the sequence is less than or equal to M. All right? Kapag merong isang real number na mas malaki sa absolute value ng lahat ng terms ng sequence, then the sequence is bounded. In other words, the terms of the sequence are always live inside the interval negative m to m. So basically, we say that a sequence is bounded if all of its terms are inside a closed interval. Okay? So yun yung pagiging bounded ng sequence. Or in other words, meron siyang lower bound at meron siyang upper bound. So yun yung different characterizations for boundedness. Now, what's a good thing about boundedness? Boundedness is an inherent property of convergent sequences. That is, if we have a convergent sequence, it is necessarily bounded. At yun yung sinasabi ng Theorem 2.2. Kapag convergent yung sequence, siya ay bounded. Okay? So pag lahat pala ng convergent sequences, kaya nating ikulong sa loob ng isang closed interval. Okay? Let's take a look at the proof. Well, what are our assumptions for this theorem? Our assumption is the sequence is convergent. And we want to show that that sequence is bounded. So we start by assuming that the sequence is convergent. So sabihin natin, convergent siya, so dapat meron siyang unique limit. Tawagin natin yung unique limit na yon as little a. So yung sequence nagko-converge kay little a. Now, sabi ng definition ng sequence, kahit anong epsilon greater than 0, there will exist a capital N such that for all indices greater than or equal to that capital N, totoo yung inequality, absolute value ng a n minus a less than epsilon. Okay? I love saying the definition kasi yun yung paraan ko dati para siya ay masaulo. So just repeat and repeat the definition. You will essentially memorize it by heart. Okay? Now, kung totoo yung definition na yun, or kung totoo yung inequality sa kahit na anong choice ng epsilon, then why not take a specific epsilon? Say epsilon is equal to 1. But actually, you can pick any epsilon for the proof, all right? So kahit anong epsilon ang piliin mo, it's just that the lecture notes shows epsilon equals 1. Because the definition will hold kahit ano pa yung epsilon na piliin natin, tama? So pinili ko yung specific epsilon na yon. So para sa specific epsilon na napili ko, which is 1, we can find a starting index capital N such that for all indices little n na mas malaki na kay capital N, yung absolute value ng an minus a ay mas maliit na kaysa kay 1. Okay? Tapos using absolute inequality, the triangle inequality, since we know this one, but this guy is larger than absolute value of an minus the absolute value of a. So we can say that the absolute value of an minus the absolute value of a is less than 1. All right. And then just use the addition property of inequality, add absolute value of an to either side, you'll get an is less than absolute value of a plus 1, which is this statement for all little n greater than or equal to capital N. So what is this telling us? Na starting pala kay a sub capital N, lahat na ng terms sa sequence ay meron na ay mas maliit na ay may absolute value na mas maliit sa absolute value ni a plus 1. So kung i-drawing natin tong statement na to, starting from capital N, all right? So we'll have capital N plus 1, capital N plus 2, and so on. Ito yung mga little n's natin. All right? Yung mga terms ng mantisa o yung domain element o yung pre-image ay nandito sa interval na to, all right? Lagi silang mas maliit sa limit plus 1 or absolute value ng limit plus 1. So the absolute value of the limit plus 1 serves as an upper bound for the terms in the sequence that are in the latter part of the list. How latter is latter? Mas malaki kay capital N yung index. Okay? So para sa infinitely many na mga terms ng sequence na ang subscript ay greater than or equal kay capital N, alam natin bounded yung mga yan. Mas maliit yung absolute value nila kaysa sa absolute value ng limit plus 1. So we're sure that all of these guys are bounded. Okay. Ang problema na lang natin ay yung mga nauunang mga terms dun sa sequence. Yun ang hindi pa tayo sure kung sila ay bounded o hindi. So here, nandito sa halimbawa, nandito yung subscript by 1, subscript by 2, subscript by 3, and so on. So we're not sure if the ANs with small subscripts or with subscripts that are smaller than big N ay bounded din. Kasi ang nakuha pa lang natin na bound ay para dun sa mga malalaki yung subscripts. Pero the nice thing is, yung mga hindi tayo sure kung bounded ay finite lamang sila. Hindi tayo sure kung bounded si A1, si A2, si A3, si A4, si A5 hanggang kay A sub n-1. Sila yung hindi natin alam kung mas maliit pa sa isang natural number. But the nice thing about them, finite lamang sila. Kaya natin silang bilangin, kaya natin silang ilista with finality. So i-collect ko sila sa isang set. Ito yung mga absolute value ng mga hindi pa sure natin na bounded. Tapos isama ko sa kanya yung a sub n plus 1. And I'm gonna choose capital N to be the largest among these guys. Alright? Sino yung pinakamalaki sa kanilang lahat? Now, I am sure that the maximum will exist. Bakit mag-exist yung maximum? Kasi nga, finite lang naman yung mga yan. So, we can, with finality, compare each element one by one, okay? At hanapin kung sino yung pinakamalaki sa kanilang lahat. Kasi nga, finite lamang naman sila. Dahil finite sila, sure ako nag-exist yung maximum at yung maximum ay isa sa kanilang lahat. So if M is chosen to be such a maximum, then we are sure na lahat na ng A sub n, lahat ng terms sa sequence ay may absolute value na mas maliit kay capital M. All right? It will be a different case or a different story if infinite yung hanapan natin ng maximum. Kapag ka infinite yung set, hindi tayo sure kung magkakaroon siya ng maximum o hindi. Right? So, pero kung finite lang yan, sure tayo meron siyang maximum. Okay? And that's the nice thing about this. We capitalized by the fact that we can bound infinitely many terms. So, mangyayari, palakihan na lamang dun sa mga absolute values ng mga hindi natin alam na bounded o hindi. At saka yung alam natin na bound para dun sa infinitely many terms of the sequence in the tail end. Okay? And so, with such a nice choice for capital N, we are sure that the sequence is bounded. All right. So I hope the proof makes sense and the different tools that we employed in the proof, because these little tools that we see in the proofs, lalo na yung mga proofs na ipresent ko sa inyo in details, they can be used for future proofs. Okay, kaya maganda na makita natin itong mga tools na to as we go along. All right. Now, what we have shown here is convergence implies boundedness. Kapag ka siya ay convergent, siya ay bounded. Now, I promised that from this theorem, we can find a, um, a divergence criterion, all right? And for that, we'll need to review the concept of a contrapositive, all right? So kung meron kang if-then statement, P implying Q, we can take its contrapositive. And from Math 101, you have seen that a statement, a conditional statement, is equivalent, at least logically speaking, to its contrapositive. And the contrapositive of P implying Q is not Q implying not P. All right? Dahil na-prove na natin yung isang statement of the form P implies Q, then we are sure that the contrapositive is also true. Kaya nga sa 101, minsan nagpo-prove tayo by contraposition. Minsan kasi mas madaling i-prove yung contrapositive kaysa dun sa actual conditional statement. Now, if we will get the contrapositive of this statement, okay, ang sabi ng statement na yan, convergent implies bounded. So convergence necessitates boundedness. Pag kinuha natin yung contrapositive nan, ibig sabihin not bounded implies not convergent. In other words, if you have an unbounded sequence, then we are sure that that sequence is divergent. So which is basically, I think, one of our divergence criteria. Okay? So kapag alam mo na yung sequence ay hindi bounded, then sure na tayo na siya ay divergent. Okay? Now, the converse is not true. Yung converse naman, pag meron kang P implying Q, ang converse niya ay Q implying P. Pinagpalit mo lang yung role ng antecedent at saka consequent. Well, that's not always true. And usually that's what people some people mistakenly apply to some logical ideas. Ito yung tinatawag na fallacy of the converse. Hindi laging totoo yung Q implying P. So parang sinisi mo yung result mula dun sa cause. So binabaligtad mo yung cause and effect relationship. And this is very prevalent, especially it's the election season. You can easily detect fallacies of the converse in most people's arguments. And of course, their postings in Twitter, Facebook, Instagram. Wag nating isali yung Instagram. Masaya mag-Instagram compared to the other sock meta platforms. Pero yan, you can easily spot these things. So let's take some time to analyze the converse and see bakit hindi totoo yung converse. Okay, nakikisali si Alexa. Pero anyway, bakit alam natin na hindi totoo yung converse kasi hindi siya nilagay as an if and only if statement. Kasi kung totoo yung converse, then this theorem could have been presented as a biconditional statement. Pero hindi. So ano ba yung converse? Ang converse nito ay, if your sequence is bounded, then it is convergent. So question, does boundedness imply convergence? I know that the answer is false, but can anybody give me a counterexample? Kaya nyo ba magbigay ng isang bounded sequence na hindi convergent para ma-disprove yung converse? So ito yung mga tipo ng tanong na katulad dun sa PS 1.4 na mag-example building kayo. Kung ayaw nyo sa true or false, pwede kayo dun sa example building. Alright? So can anybody, probably aside from Charles, give me an example of a bounded sequence that is convergent? Bakit except Charles? May bonus na kasi si Charles eh. Pero sige, Charles, you can answer in the chat. Pero sige, how about the others? Chance to get some bonus points. Bounded sequence na hindi convergent. And a mere statement of such a sequence is enough proof that the converse is not true. So, ibig sabihin, na-prove na natin effectively yung converse, na-disprove natin effectively yung converse ng Theorem 2.2. Sige nga. Bounded sequence na hindi convergent. Yes, Anna, go ahead.
Yung previous example po, sir, yung -1 and 1, napaulit-ulit po.
All right, so that's why I wrote it again. All right, kasi in-anticipate ko siya magagamit natin. Remember the sequence consisting of -1 and 1s in alternating order. So meron -1, comma 1, -1, comma 1. We have shown that that is divergent, but it is bounded, right? Bounded siya by yung absolute value ng mga terms na yun ay less than or equal kay 1. So kaya nating ikulong yung mga members ng sequence na yun sa closed interval -1, 1. If you're feeling extra generous, then pwede mo siyang ikulong sa interval -10 to 10. It doesn't matter. So bounded siya, pero siya ay divergent pa rin. Okay? So ibig sabihin kapag ka-bounded, siya ay hindi convergent. Alright? Hindi siya necessarily convergent. So because we have found an example of a bounded sequence that is divergent. Si Jonathan ang sabi niya ay sine ng 1/n. Okay, yeah, definitely that is bounded, Jonathan. Bounded siya between -1 and 1. Pero siya ay, I think it is convergent. Kaya natin siyang i-prove to converge to 0. Okay? Pag tiningnan natin yung squeeze theorem. All right? But nice try, Jonathan. Yeah. But that is a convergent sequence. So kailangan ko mag-isip ng isang bounded na divergent. Yeah, but that's fine. Nice try, Jonathan. You'll earn bonus points for that nice attempt. All right. Now, okay, yung pakabila naman, kaya niya ba magbigay ng bounded sequence na convergent? Which is basically sort of a trap for the fallacy of the converse. Kasi pag nakaisip ka ng isang bounded sequence na convergent, yun na pala, sinagot na ni Jonathan yung question ko na yun. Meron mga bounded sequence naman na convergent, katulad ng binigay ni Jonathan sa chat na sine ng 1/n. Siya isang bounded sequence, bounded from -1 to 1, pero siya ay convergent. So kapag ka nakakita ka ng example na bounded implying convergence, all right, hindi yun enough to prove the converse, right? So just keep it in mind. That's the usual mistake students make, especially the lay people make, right? Pag nakakita ng example, i-generalize na totoo yan for all cases, all right? But showing a counterexample is enough to prove the falsity of a statement, while it is not enough to show an example to prove the truthfulness of a general statement. Okay? So yun. Theorem 2.2. And I think, yeah, that ends section 2.1. And let's take a 2-minute break. Tapos, tingnan natin yung limit theorems. Hopefully, mapagkasya ko in 10 minutes yung limit theorems. If not, I'll borrow 5 minutes again from you guys. Okay? So, break muna tayo, mabilis, before we go to the algebraic theorems. By the way, medyo binabagalan ko talaga ngayon. Aside from I am distracted by my runny nose. All right. Ayokong damihan yung i-discuss kasi nagpa-problem set pa naman kayo. But I find the section 2.1 and 2.2 fine because mga results to na alam na natin from before. So parang recall lang talaga to ng math 38. So kaya I think okay pa rin naman natin siyang pag-usapan today. Okay. All right, so now let's continue. So let's look at the limit theorems. Well, ito yung sinasabi ko ng mga theorems na posibleng makatulong sa atin to find the limit or to prove the limit of a sequence. All right? Kasi mahirap gamitin yung definition over and over again, especially if the formula for the end term of the sequence is quite complicated. Kasi mas marami kang inequalities na kailangang i-manipulate and so on. Now, one way to solve those problems is that we can break down the given sequence into some component sequences via some algebraic operations, and then rely on the theorems that we will prove today para makonclude kung saan nagko-converge yung isang komplikadong sequence na kaya nating isulat in terms of algebraic operations with terms of a sequence that we know to converge to a certain value. All right? So that's why you will see that the assumption of theorem 2.3 is the limit of two probably simpler sequences, all right? So meron tayong sequence ng mga AN na nagko-converge kay A at sequence ng mga BN na nagko-converge naman kay B. Tapos we are considering here an arbitrary constant C. And then let's look at the statements. Well, statement number 1, kapag ka binuo mo yung sequence consisting of the sums of the corresponding terms in the sequence AN and BN, so essentially, kumuha ka ng bagong sequence na ito yung itsura ng mga terms nila, alright? Etong sequence na to, which is obviously more complicated than AN and BN, will still converge, provided that A and B are convergent, and more than that, they will converge to the sum of the respective limits of AN and BN. Okay. So basically, ang limit ng sum ay sum ng limits. Yung B, ganun din. If you take the product of corresponding terms in your sequence, the resulting sequence will still converge, and they will converge, or the sequence will converge to the product of the limits. Tapos, pag meron ka naman sequence AN, minultiply mo lahat ng terms nila by a constant C, the resulting sequence is still convergent, and it will converge to C times the limit A. Tapos finally, kapag ka meron kang BN, pagka binuo mo yung BN over AN, so here I'll need to insert, so paki-correct to, this is a typo. I need to assume that AN is also not equal to 0 for all N. Hindi ko to napansin last semester, pero yan, napansin ko siya kanina nung kabilang lecture, alright? Kasi nga kapag kasi AN ay nag-0, magiging undefined yung isang term dun sa sequence. So dapat ang ANs ay never nagsi-0 at yung limit ay hindi nagsi-0 para yung quotient sa magkabilang side ng equation ay magiging well-defined. Okay? Then probably let's prove two of these statements. Okay? Dahil dalawang ipoprove natin, kailangan ko sigurong mangutang. Pero let's try to do it ng oras. But let's try to do it fast, okay? Just raise some questions if some are not clear, okay? Now first, let's prove one. Limit ng sum ay sum ng limits. Okay. Now, of course, we know that the limit of AN and BN exists and are equal to A and B respectively. So let's just apply the definition of the limit, all right? So ganun din, katulad kanina, nag-exist yung N1, nag-exist si N2, such that this absolute values are both less than epsilon over 2. Bakit epsilon over 2? Kasi nga, makikita nyo later na kailangan ko silang i-add para mapakita yung limit ng AN minus BN. Bakit ko nalaman na kailangan ko silang i-add? Kasi di ba gusto kong i-prove ang limit na to ay equal kay A plus or minus B. If you're doing it by definition, then we need to investigate what happens, all right, to the difference or to the absolute value. Oops, ito ko na siya isulat. Ang kailangan nating imbestigahan ay yung absolute value ng AN plus BN or plus or minus BN. Yan yung terms dun sa new sequence natin. Minus yung kiniklaim na limit. Ang kiniklaim na limit ay A plus or minus B, so minus A plus or minus B. Okay? Ang ibig sabihin lang nung plus or minus, kapag ka plus yung pinili mo dun sa left side, plus din yung pipiliin mo dun sa other side. Pag minus yung pinili mo sa left side, minus din yung pipiliin mo sa right side. So parang ano yan, one-to-one correspondence. Okay? Kung ano yung nasa taas, yun yung nasa taas. Pag ang pinili mo yung nasa taas, so dun sa kanan, yung nasa taas din yung gagamitin mo na sign. Okay, but I can rewrite this. Okay? Equal to kay an plus or minus bn. Tapos i-distribute ko lang yung negative sign. So magkakaroon ako ng negative a. Then the negative sign will also be distributed to plus or minus. So minus times plus, that's going to be minus. Minus times minus, that's going to be plus. So yung nasa kabila, minus plus na yung magiging sign. So ibig sabihin, kung plus yung sign dun sa una, minus yung huling sign. Kung minus yung sign dito, plus yung nasa kabilang sign. Alright? Kaya nagkaroon tayo dito ng minus plus. So ito yung gusto nating imbestigahan. Tapos, gagamit ako ng triangle inequality again. I will group an and a. Kasi ito yung makikita nyo mula sa inequality na to. So, i-group ko yan. Tapos, ang i-group ko naman sa kabila, yung plus or minus bn at saka yung minus plus b. Alright? Ang kagandahan sa plus or minus bn, minus plus b, magkaiba sila lagi ng sign. So it's either bn minus b o kaya negative bn plus b. Kaya lang, pag nag-triangle inequality ako, malalagay sila sa magkahiwalay na absolute value. So kasi ang mangyayari dito, magiging less than or equal to sa an minus a plus absolute value ng plus or minus bn minus plus b. Alright? So, pwede ko, di ba sa absolute value, pwede niyong pagpalitin kung sino yung naka-minus kanino. Kasi that's just about multiplying by the absolute value of negative 1. So ito, okay na yung first. Ito pwede ko itong ihatian sa dalawang cases. Maging absolute value ng bn minus b. Tapos ito ay absolute value ng negative bn plus b. Alright, yun yung dalawang cases. Okay na to kasi ito yung nandun sa inequality. So that's fine. Pero dito, para masulat siya na kamukha nung nasa inequality, pwede ako mag-multiply ng negative 1 sa loob ng absolute value. Kasi ang absolute value ng negative 1 ay 1, tapos ang absolute value ng product ay product ng absolute values. So, pwede ko siyang gawin sa loob ng absolute value. Pwede ako mag-multiply ng negative 1 and still the answer is equal to the previous absolute value. So pag nag-multiply ako ng negative 1, magiging absolute value ito ng b minus bn, which is the same guy as what we have when we apply the definition of the limit being equal to b. Alright? Kaya ako nakuha itong inequality na ito. And again, I want to guarantee that these two guys are true at the same time because here I need to use the fact that they are both less than epsilon over 2. And we learned earlier that we can guarantee the satisfaction of this two inequality by choosing capital N to be the larger between N1 and N2. Or pwede rin yung sinuggest kanina ni Charles na piliin ko si capital N to be N1 plus N2. Because if N is larger than, or little n is larger than any of those two choices between N1 and N2, we're sure that little n will be greater than both N1 and N2. So nag-hold yung dalawang inequalities. At dahil nag-hold yung dalawang inequalities, pwede ko itong masabi to be less than epsilon over 2 plus epsilon over 2, the sum of which is equal to epsilon. Okay? Now, in summary, we have shown that for all epsilon greater than 0, there exists a capital N, which is equal to the maximum between N1 and N2, such that for all n, or for all little n greater than or equal to capital N, this absolute value is less than epsilon, which is the very definition of the limit. So kung sino man yung naka-minus, kung sino yung subtrahend dyan, siya yung limit. Ang subtrahend natin basically ay si A plus or minus B. And that's exactly what we claim to be the limit of the sequence consisting of the sums of the terms of the two individual sequences. Okay? Any questions with that? All right. So now, siguro gawin natin tong habol ko lang yung part, let's see. Nagkabaligtad pala yung label dito. Ito dapat ay C. Ito dapat ay part B. Okay. Kakayanin ko ba in 5 minutes? Siguro wag na nating i-push. Maybe we can stop here. I'll just share with you the proof of part B on Thursday. We'll start there. But do you guys have any questions about the results that we have? Sorry kung medyo nabagalan kayo sa discussion today. I purposely did that para konti lang yung makover natin ngayon because you're doing the problem set pa rin. So I don't want to make it an overload of information. But we'll pick up the pace on Thursday kasi kailangan natin maghabol ng konti. Though hindi ko naman is-sacrifice yung details, so yung discussion natin ng details, alright? But let's try to cover as much as we can before the reading break, which will be week after next. Tapos, pag medyo maganda yung naabot natin, baka hindi na rin ako magpaklase on the Holy Week. So para meron kayong 2 linggong magkasunod na bakasyon. Pero, titingnan ko pa, let me see by next week kung kakailangan nating mag-meet ng Holy Tuesday. Alright? Kasi yung Monday, Thursday, sure naman tayo na holiday. So, ang babantayan na lang natin, magde-declare ba tayo ng holiday sa klase for Holy Tuesday. So, let's see. Okay? So questions or other concerns about this or about the problem set? Okay, so if there are none, you're welcome, Charles. That's the least I can do for you guys. Okay, so if there are no questions, then I hope you enjoy the rest of the day. Good luck with the remainder of your problem set. Happy solving. And let's see each other again on Thursday. Until then, keep safe, everyone. Bye-bye.